Hey, how's it going? Welcome to lesson 3.5. 3.5 says this. I can calculate the amount of energy transferred during a phase change. If we look at our descriptor sheet, 3.5 is listed here. That's the one we're taking care of in this video. Let's flip back and let's get the lesson started. When I look at skill 3.5 and I read it, it says calculate the amount of energy. What they're asking us to do is quantify the amount of heat there is in something or in a change. So quantify the amount of heat. Heat in the world of chemistry is signified with the letter Q. So what this equation is telling us is that these three variables to the right, these two get multiplied to give us a value called Q. And what Q stands for is something called joules, Joules. And it's very similar to a calorie, but just a little bit different. It just tells us how much heat there is in a specific system. The M here to your right stands for mass. And then this H sub F or H sub V stands for heat of fusion. And this is a constant that we're going to use to calculate the energy of a phase change. So we'll go ahead and write that down. So we call this heat of fusion. And again, you have two choices. Your one choice is H sub V or H sub F. One thing that I cannot stress enough is that this equation is only used for phase changes. If there's a temperature change, we cannot use this equation. We'll see that in the next video, but this equation only works for phase changes. If we read a word problem and establish that it's a phase change and we read the words melting or freezing, here's what your equation is going to look like for Q. It's going to say heat is equal to mass times, and the constant we're going to use now is 334 joules per gram. If you read your problem and it mentions anything about boiling, evaporating, or condensing, then here's the equation that we have to write. It's going to look almost the same, but just a little bit different. It's going to say Q equals M times 2,260 joules per gram. Before we start the word problem below, let's just recap the proper units we need for our numbers. And remember, joules is going to be represented as a J. M is going to be represented as a G for grams. And then H sub F or H sub V, notice they give it kind of a funky one. They call it joules per gram. It's a fraction. So depending on what we solve for, those are the units you need to put accordingly so. We'll go ahead now and use our phase change heat equation to solve for Q in a very simple example. So hopefully this kind of looks familiar. I've kind of tweaked it a little bit, and I'll tell you what that is here in a second, but here's what it reads. 20 grams of ice is taken out of a freezer and put onto a countertop. The ice begins to melt and eventually turns into a small puddle of water. So again, this is an LOL chart that we filled in the previous video. And if you'd like to see how this was filled out, please go ahead and reference that video. But to save time today, we'll just talk about what's going on. So we have a frozen ice cube, frozen solid. We know that the ice cube is definitely taking in heat from its surroundings. That's why it's beginning to melt. And then notice that the phase changes from liquid to gas. From solid to liquid. I know from reading the problem that this is a phase change because I read the key word here. It says melt, right? So as I scroll back up, notice that again, we read the word melt here, and that's going to be very important in just a moment. Something I've added to the problem is a mass. Before it didn't say 20 grams, now it does. And this small addition actually allows us to quantify the heat. So let's write down our heat equation here, or actually decide which one we need. So because we read the word melt, and we circled it here, we're going to follow the arrow. This is the equation we're going to need in this problem. Q equals M times 334. So heat is equal to mass times 334 joules per gram. Let's put a parentheses around this to keep it organized. So I just found the heat of fusion. Now what we have to do is go ahead and find something that we can plug in for mass, because when we multiply these numbers, it will give us the Q. So let's see if we can find the mass. Oh, here it is. So when we read the problem, it says 20 grams of ice. So this is exactly what we need, 20 grams. So we'll take our eraser. We'll erase this. We'll put down 20 grams. And now all you have to do is to grab your calculator and multiply these two numbers together. So we'll do 20 times 334. And here's what we come up with. Q is equal to 6,680 joules. And that would be your final answer. So we've come up with our answer here, but there's one last thing we have to talk about. Values for Q can either be positive or they can be negative. And it's all dependent on how this arrow here is facing. When a system is taking in energy, the heat value will be positive, right? So if we get an arrow that's going in, then we get a positive answer. If we get an arrow that's going out, it means the system is losing energy and our answer will be negative. So as I'm looking here, it looks like our answer matches this arrow going in, and therefore we're going to leave this answer as a positive one. So that just about concludes this video, and if I can reinstate one thing, remember the equation Q equals MH only applies to phase changes. As always, thanks for listening and have a great day.